Okay, quick reminder that what we found at at the end of the last video or during the last video is that extrema can only be found at critical points, in other words, where the derivative is equal to 0 or does not exist, and endpoints. And of course, that's on a closed function. So let's do another example. Example number 4, f of x equals 1 over the square root of 4 minus x squared. And first of all, we're going to need the derivative. So I'm going to rewrite the function as a power 4 minus x squared to the negative 1/2. Whoops, didn't mean to put the derivative symbol in there. And then I'm going to take the derivative. Power rule says negative 1/2 4 minus x squared to the negative 3/2 times chain rule. The derivative of 4 minus x squared is negative 2x. The negatives cancel, the 2's reduce, and I am left with the fact that the derivative is x over, let's see, how do I want to write this? The square root of 4 minus x squared cubed is probably as easy as any. So critical points. F prime is equal to 0 when x is equal to 0. And so we'll do a quick calculation of the y value. Y of 0 is 1/2. And I feel like saying yes. Yeah. Okay. F prime does not exist when x is equal to plus or minus 2. And of course, we might note that the domain of this function is actually negative 2 to 2. It does not include the endpoints, and it doesn't include anything bigger than 2, or the absolute value bigger than 2, because you would get 4 minus something bigger. So the domain of this function is only inside negative 2 and 2, which means that we don't have endpoints. So the endpoints do not exist. The derivative does not exist at numbers that are not in the domain of the function. So the only minima or maxima would have to be right there at x equals 0. So then the only thing we need to know is this a minimum or is this a maximum? Well, if I start at x equals 0 and I have x increase from 0, in the positive direction or the negative direction, it doesn't really matter. 4 minus x squared is going to get smaller, which means that the function is going to get bigger. I'm not thrilled with that explanation, honestly. Oh yes. Because here I am. I'm sorry. I'm looking at the derivative instead of the function. Yes, looking at the function. As x increases, 4 minus x squared decreases, and therefore the function increases. Whoops. Sorry, still on my laser. And therefore, x equals 0 is a minimum with a value of y equals 1/2. That is the lowest that this function ever gets. So it is an absolute minimum, and there are no other minima or maxima. All right. Let's talk about some exceptions. Critical points which are not extrema. So first of all, let's look at y equals x cubed. We know that this function goes like this. The derivative is 3x squared, and y prime is equal to 0 at x equal to 0. But notice that this is not a minimum or maximum because it's increasing, stops increasing for a second, and then continues to increase. So we do not have an extreme value there. And it's important, this is why we check, this is why we test. We look at the endpoints, we look at the values, we see what happens to the function. And also why, at least in our curriculum, we spent so much time exploring these functions back in Algebra 2 so that we would recognize what they look like and be able to analyze. Let's look at another one, the inverse of this function, which is the cube root of x. And because it's the inverse, we know that it looks like this. And right here, the derivative does not exist either. It is a vertical tangent. But again, there is no critical point. And so in both these cases, there are no extrema, even though each one has a critical point. Again, very important that we test these. All right, another quick example. We'll call this example number 5. We're looking at the function, and we're going to do a piecewise function here. So we've got 5 minus 2x squared for x less or equal to 1. We've got x plus 2 for x greater than 1. Quickly, let's take the derivative. F prime of x equals negative 4x for x less or equal to 1, and it equals 1 for x greater than 1. And at x equals 1, f prime of 1 is negative 4 or 1. And notice that you know what, I'm going to change that to f prime of x. The one-sided derivatives are not equal. Therefore, f prime of 1 does not exist. So there's a critical point right there at x equals 1. Let's look at f prime of x equals 0. Well, 0 is less than 1, so we're looking for negative 4x equals 0, which means that there is a critical point at x equals 0. So we've got 2 of them so far. And that's it. Those are our 2 critical points. So let's do some quick calculations. We'll change colors to do our calculations. F of 1 is equal to, well, we're using the 5 minus 2x squared when x is equal to 1. So we have 5 minus 2, which is 3. F of 0, also using 5 minus 2x squared, so that's 5. And then our endpoints, well, notice that we don't have endpoints because this is not a closed, a bounded function. It's not inside a closed interval. So there are no endpoints. What does this function do in either direction? Well, as I go to the left to negative infinity, I'm dealing with the first equation, x less or equal to 1. And notice that the function is going to go to negative infinity. And as x goes to positive infinity, I'm dealing with the function on the right, x plus 2, which means that the function goes to positive infinity, which means that these are local maxima and minima. Here's what we have. We have a local maximum, and this must therefore be a local minimum. And if I want to confirm this, what I would do is I would sketch the function. I would say I'm at negative infinity, and I come up and I reach some value, and I come down and I reach some value, and then again I go up forever. Well, that has to be 5, and this has to be 3, because it wouldn't make sense otherwise. So I've got local max, local min. Let's add the words local min and local max, and we notice that we have no absolute extreme values. All right, I'm going to stop there. When we come back for the next video, we'll look at a couple more functions, and we'll look at a graphical method of determining these things.